So I just hit the record button, just a heads up, and it will, just to let you know that it will be available. It's in the 60s here in Miami. Burr. I know, Rebecca, I was living in Atlanta in Candler Park, and we got like 2 inches one time, and the city shut down for 3 days. And then I moved out here, and we get a lot of snow, and everything just keeps on keeping on. It was kind of an adjustment. Hi, Pam. Hello, Linda. Hi, Susan. Good to see you again. Yeah, Francie, I think we call that a microclimate. All right, so it is 1 o'clock. I see some people still trickling into the room. We had a pretty big registration list for this, so I might wait just a few moments, check the email, make sure everybody's able to log in okay. All right. So like I said, we do have a jam-packed day today. I want to get started as soon as possible. A lot of people are introducing themselves in the chat box. I have that poll question up in the left. Which 2017 events did you program for in 2017? And let's see, on that right-hand side, that pod that says files to, that's just some of the links we're going to be talking about today. You can go ahead and download it and follow it along there. We have so many links and so many resources. I am not going to ask our chat support specialist to just throw them in the chat box the whole time. So you can feel free to download that link. And I'll give about 1 more minute for people to trickle in and fill out the polls, and I'll broadcast those results, and we will get started. Just so you guys all know, this webinar is being recorded. It'll be uploaded to YouTube probably within a day or two. Hi, Teresa. Thank you, Greg. All right. right, so I'm going to go ahead and broadcast these results from the poll. Let's see. Maybe if I end it. Are you guys seeing the results there from the poll? Looks like, of course, 92% of people did programming around the Great American Eclipse. Not too much of a surprise. We're going to talk about some ways today that you can kind of repurpose those things that you may have done for the eclipse for another big STEM event that is happening in 2018. See, Earth Day, that's always an easy one. Or not easy, but there's a lot of different things you can do for it. International Observe the Moon Night, wonderful. And I'm excited to see some folks did programming around the Cassini mission grand finale. We house some of those research scientists on the imaging side of things, so they get that raw data, they make those images. So I'm glad to see that some folks were doing. Yes, Teresa, I meant very, very popular. No, I just mean there's a lot of flexibility with your programming for Earth Day. Wonderful. So I'm gonna go ahead and close this. And I'll just put this link bank right up here, give you guys a few more seconds to download it. This link bank is just what we're going to be talking about today. I'm going to be referencing a lot of links. You can click on the PowerPoint slides to access them, or if you want to download the PDF with all the links ahead of time, that is fine as well. And we'll send that list to you afterwards. Okay, wonderful. My name is Brooks Mitchell. I'm the education coordinator here at Space Science Institute. StarNet is one of the projects that we run that kind of brings these webinars to you guys, along with a few other projects. So just wanted to quickly point out, this is going to be recorded. It'll be available in just a couple of days. You can test your audio. If you're having any audio problems, then you can't hear this message. But you can test your audio by going to Meeting and then Audio Setup Wizard. Okay, so I just wanted to cover today's agenda, and this is really just the events that we're going to be talking about. It is jam-packed. I have a lot of things to cover, a lot of resources to give you guys. But first, we're going to start with Engineers Week. That's right around the corner, and there will be another webinar on Engineers Week in early to mid, I think January 9th is the date on that. We'll provide information for that. Earth Day is April 22nd. We're going to talk about the NASA connection to Earth Day. The NASA InSight mission, we're really excited about that because it gives you 2 programming opportunities in early May and in late, let's see, should not have jumped just then, and in late November. So there's 2 programming opportunities for you there. The Parker Solar Probe launch, that is NASA's mission to touch the sun. That'll be taking place in late October. And Lights On After School, not necessarily a STEM event, but it kind of is because it's a way to partner with your after-school providers in your neighborhood or in your community that might be doing STEM. So it is a STEM event. An International Observe the Moon Night, October 20th. Oftentimes those are flipped around because the dates are so close. But this year, International Observe the Moon Night will be October 20th, and Lights On After School will be later at October 25th. And of course, we want to thank our partners that help us put on these awesome projects. So NSF, we have a couple of projects with NSF and NASA. Our NASA at My Library project is, of course, funded by NASA. So we're very grateful for our partners and our opportunities to do this programming. StarNet, as I mentioned, that's kind of our online community for professional development. So there's webinars, newsletters, blogs, forums, videos. I highly recommend that you sign up. We'll only send you like 1 newsletter a week, or 1 newsletter a month, I should say. We won't bombard you because that would be a lot of work for me and Greg, mostly Greg. So you should definitely sign up, get awesome, valuable resources and webinar announcements. And in terms of upcoming webinars, the 2 kind of event-focused webinars, we may have 1 or 2 more in between, not focused on events. But we have Building a Better Program for Engineers Week. That'll be Tuesday, January 9th. You can already click and register there for that webinar. And we're just going to be going over hands-on activities, fun engineering activities that you can do for Engineers Week. And then on Tuesday, March 6th, that is the tentative date. We have not set up registration, but we will be doing Celebrate 60 Years of Earth Observations with NASA. So we're hoping to have a guest speaker and talk about some ways that you can do earth science programming or other types of programming and activities for that April 22nd Earth Day. Teresa, I see you typing. You might jump in and say, "Oh, I can't do March 6th," but we'll settle on a date. It'll just be in early March, and we'll make an announcement and put registration up about a month beforehand. So the STEM Activity Clearinghouse, we're going to be referencing that a lot. Awesome, Teresa. We're going to be referencing the STEM Activity Clearinghouse quite a bit today. It is our kind of our go-to for STEM activities, as you might imagine. This one in particular is Sun Cookies. This is a really fun and tasty activity. But if you're not familiar, please go. It's very easily sortable. We have different collections, or for like kind of different themes. So if you want to do a space science lesson, of course we have a collection just for that. If you want to do an earth science lesson, there's collections just for that. So we'll be referencing that a lot today, and if you follow our links, you'll definitely have a chance to visit it. Let's see. You guys will give me just 1 second. I'm going to lower the video quality on my webcam. It's lagging a little bit. I want to make sure that everything looks good. Okay, so we're going to jump right into Engineers Week. Like I said, this is right around the corner. You've probably already planned for your early 2018. And so I'm just going to kind of touch on it because we'll be covering it more in early January on like specific activity ideas that you can do. So Engineers Week, I just found this out. It's actually been going on since 1951, and it is always on the week of George Washington's birthday. And there is a connection there. It's not just coincidence. George Washington is considered to be one of our nation's first engineers. I believe he was a surveyor. But anyway, Engineers Week is a great opportunity to bring engineer programming to your library. It's a way to celebrate how engineers make a difference in our world. I think sometimes people don't realize all the infrastructure around you, the road you're driving on, the building your office is in. You can thank an engineer for that. It's meant to increase public dialogue about the need for engineers. So getting that interest built in kids and adults that might want to go into that profession. And it's meant to bring engineering to life for kids, educators, and parents. So it's meant, excuse me, to make engineering fun. All right, so I'm just going to point you in the direction of some of the many engineering resources that we have. So our big landing page, which if you get one link out of all this, get the landing page link. That's going to be kind of our home base for Engineers Week, where we'll post information about webinars, activities, etc. As I mentioned, that Building a Better Program for Engineers Week webinar will be on Tuesday, January 9th at 1 p.m. Mountain. You can go ahead and register there. And luckily, we have developed some specific engineering collections on our STEM Activity Clearinghouse. It's actually for another project we're working on. We call it Project Build. But these 4 collections are jam-packed with fun activities and fun specifically engineering activities. So Spantastic Bridges is talking all about strong shapes and different types of bridges, a lot of bridge making activities. Design to Survive is talking about how we can prevent, or not prevent natural disasters, but design around natural disasters to make our infrastructure more safe. So there are a lot of fun activities there, like preventing a landslide from happening, or what's the best way to build a house to make sure it doesn't get overcome by storm surge. So a lot of real life applications there with that Design to Survive collection. Clean Up Our World is what you might think. It's about how we can use engineering to more efficiently keep our world clean and clean up pollution. So there's a lot of great activities there, and there's a little bit of an earth science tie-in with some of those activities too. So you could maybe do that for Engineering Week and Earth Day. And then Power from Nature is all about just alternative energies, renewable energies, ways that we can use engineering to be a little bit more efficient or get cleaner power, or use our natural environments and the motions of nature to power our world. So I have 2 other links down there. Discover E, they kind of have the main Engineers Week homepage, if you will. And there's a lot of great resources on Discover E. And Dream Big it's a film that was in IMAX, but it's kind of tied in with Discovery a little bit. And Dream Big has awesome activities. We work closely with the folks at the American Society for Civil Engineering on a couple of projects, and they really have great activities. So head over to the Clearinghouse, head over to Discover E, head over to Dream Big, and make sure, and you should not have a problem finding activities for Engineers Week. Okay, so I included this. This is something we've developed again for a different project, but it's kind of useful to use. It's the we call it the engineering design method. So think, build, test, and do it again. I personally have a science background, so I think more in terms of the scientific method when I do activities. But the engineering method's a little bit different. So it's all about that redesign aspect. You kind of want to encourage. You don't want to encourage kids to fail, but if a child is making something and it doesn't accomplish the task at hand, or the design fails, it is great to, like, that's a great teaching moment. It's like, okay, well, what didn't work? Let's redesign it again. In our last webinar, I built a little car that did not work at all. It's like you blow up a balloon, you attach it to the end of the car, and it's supposed to scoot on. It didn't work at all, but I had a very big learning moment and made another one to learn how. So that redesign aspect is really big for engineering. Yeah, and Kellyanne said kids are really responding well to that graphic. It's simple, it's easy, and it kind of shows that this is all just a big cycle, and you're never really done with that engineering method. You're always redesigning and trying to make it better. All right. Yeah, Susan, I believe you could, I'll let Kellyanne answer, but I believe you could use that graphic. There might be other iterations of it online too. That's just kind of the one that we came up with. So daylight in a bottle is the activity that I kind of wanted to highlight, and I don't have a ton of time to do a full facilitation, so I'm just going to kind of show you guys what this activity is all about. It's about the idea of daylighting. It's about the idea of daylighting, so not using our artificial light bulbs and whatnot to create light in a room, but to use natural daylight. So it really kind of deals with the idea of light and refraction. And this is something that is actively being used in a lot of third world countries. And this idea of daylighting is actually being used, in architecture all around the world. So daylighting, the specific daylight in a bottle, all you need for this is so easy. All you need is a water bottle, water, and maybe just a little bit of bleach to make sure nothing funky starts growing in your water bottle. So we have our own made, say that with parentheses because it's so easy. You can do this all with recycled, repurposed activity. So we have our water bottle right here, right? Everybody could get access to a water bottle. And I don't know if you've ever shown a light through a water bottle, but it produces quite a big refraction. Let's see. You guys can probably see it glowing on the webcam there. So if you put this in a dark room and maybe you only have a small hole, a small little portal to the outside, and you have daylight shining it, it really illuminates a room well. So that within itself, yeah, maybe they can pour the water in themselves. Oh, wonderful! Thank you, Kellyanne. So Kellyanne just posted that that design process graphic if anybody wants to grab that, and I'll try to get it back in our link bank too that I send out. So you just have a water bottle. Again, add a little bit of bleach. It's just like a small amount, maybe a cap full, to prevent any organisms from growing in there. And then you can find a portal to the outside. You could cover a window and just put the water bottle in there and let it illuminate a room. So the way that we kind of have done it, or if I were to lead this activity with a group of kids, there are a few different things you could do. If you're at home, maybe you could have your kids build a fort and have that as their hut or whatever that needs daylight brought into it. But let me turn off the lights real quick. Try not to knock over my coffee cup. But right here, this is just like your ordinary paper bag, right? Brown paper bag. And we have cut a hole in the bottom of it. Let's see. You can see my finger poking out there. And so this is actually something that one of my colleagues did with her kids at home. You take your bag, you get it really, really dark. It would probably need to be a bit darker than this. Yeah, the Trader Joe's bag. And you have your kids kind of write like a secret message in there. So I think Kellyanne's kids wrote, "I love STEM," or "Engineers love solving problems." You put your water bottle in one side. Now, I don't know if this will show up on camera, but it's fun to try anyway. Let's see. Look at that. It is really bright. And so you could write secret messages, have your kids write secret messages, and then illuminate it with that water bottle. So easy, fun, and so cheap. An easy way to repurpose some of your recycling. So just a fun activity idea. You can follow the links there. There's also a great YouTube video about a project called Leader of Light. And if you follow that YouTube link, it's a great 2 or 3 minute video that talks about how this is actually being done in third world countries. This isn't just a fun activity for kids. This is something that is being done to reduce energy costs around the world. Okay, we are now to Earth Day. Now I wanted to kind of turn it over to you guys. What has your library done successfully in the past for Earth Day? You can throw it in the chat box. I might not be able to, probably won't be able to read all of them, but I'd like to see a few fun ideas before we move on. There's just a lot of different things that you can do for Earth Day. I'm going to talk about one NASA connection in particular, but it can go around a wide range of subjects from science to definitely tech and engineering or art. There's a lot of different ways to celebrate Earth Day. Nice. See a lot of art, recycled art, perennial garden. Oh, cloud activity, very fun. Steam story walk in the library park. Oh, that sounds fun. Purchase seedling trees from the Missouri Conservation Department that we gave away to our patrons at Earth Day celebration. Just post some of the beautiful Earth Day posters. That's right. And there's actually a book that NASA put out called Earth as Art. I pulled a graphic from it that will be on the next slide, but it is a wonderful, beautiful book. It's on my coffee table at home. Yeah, Earth without art is just eh. Presentations on stormwater management. Very cool. A rain barrel raffle. These are wonderful ideas, guys. So I'm going to talk about kind of the NASA theme, or the theme that we'll be rolling with for training on the Globe Observer. Wonderful. We'll be talking about that. Very cool, guys. So the 60 years of Earth observations from space. So people think about, what NASA does or what, our current efforts are in outer space, if you will, and they think we're looking away. We're trying to find distant planets, distant stars, things far away from Earth. But actually, a big part of what NASA does is looking back at the Earth. Since 1958, that was the date of the year of the first U.S. satellite Explorer 1. And being able to look back on Earth provides us with so many opportunities to understand exactly what's going on and climate trends and deforestation, so many important topics. So this year, we want to celebrate those 60 years of doing those Earth observations from space. So different programming ideas for Earth Day. You guys seem like you're already on top of it, but there's so many different things across so many different subject ideas that you can do. Yeah, so Teresa's kind of heading up that effort. You can see her in the chat box. And what we're planning, or what NASA's planning on doing this year for this idea of 60 years of Earth observations is kind of taking your suggestions, taking your helpful hints from last year, if you participated last year, and to kind of use that to provide the 2018 resources. So you can see there's plenty of things you can do: photography, recycling, gardening, nature walks, citizen science. We'll be talking about that in just a second. Agriculture, a story hour. There are a ton of different ideas and ways to incorporate that. It's a very easy STEM event to tie into. Yeah, thanks for that teaser. So here are some different resources, and I want to talk about the NASA Globe Observer. I assume most of you people are familiar with this idea of citizen science, and I really like citizen science because you don't have to be a typical stereotypical scientist to contribute to the scientific community. So the NASA Globe Observer allows you to kind of upload your own information, record your own data, record your own information, and use that to help NASA verify some of their satellite observations. So I believe right now it's the Cloud Observer. So you can take pictures of clouds, you can document what kind of clouds are in your area, what the cloud cover is like, and NASA will use that to verify what their satellites are reading. And I believe there's a mosquito observer. Teresa, you might be able to say more about that in the chat box. I haven't used the mosquito observer, but again, it is contributing to that idea of citizen science and the idea that everybody can contribute to the scientific community and the data sets. So a very, very cool application. I have the link to it right up there. You can click on it. Greg, if you Globe Observer Mosquito Habitat Mapper. Okay, so you were like, seriously, guys, you were contributing to very, very, very important scientific data. And yeah, Greg put the link in there, and there was one for the eclipse as well. I believe that was recording like temperature changes. So I personally wouldn't have taken my eyes off the eclipse to look at my phone, but for those of you that wanted to contribute, that was a great resource. So I mentioned we'll be doing an Earth Day webinar that's going to be on March 6th. Look for registration to open in early February for that. If you want a recording to the 2017 Earth Science for a Better World, that was before my time here at SSI, but they did a great job with that webinar, so you can check out that recording right there. Temperature and clouds over 100,000 observations in one day. Wow, that is amazing. And then I just picked out a few of my favorite Earth Day activities that you might want to. If you're setting up your programming now and you need to have your activity ideas now, you might check these out. So Who Dirtied the Water? That can actually be found in an engineering collection because it kind of ties into both. But it's a really fun role-playing activity. So with Who Dirtied the Water, you have a big gallon of water. You give the kids each a pollutant, something like coffee grounds or maybe oil in a little canister or a little vial. Then you read a story about your neighborhood. So I'm here in Boulder, Colorado, and the story I read is about, how it was first settled. The first inhabitants were the Arapahoes, and then European settlers moved in. And as you tell that story, you kind of say, well, then as the settlers moved in, they threw their trash in the water, and then you have a kid or a patron dump their pollutant in the water, and they can all see it kind of mixing together, and they can see how those maybe small pollutants over time really add up and cause a big, gross, nasty-looking water body. UV Kit is fun. It uses UV beads, so beads that change color in the presence of UV light. And there's a lot of things you can do with that. UV Kit in particular is about kind of dressing your little figure to prevent UV radiation. But if you just have a bag of UV beads, you can do a lot of programming with that too. Low-tech water filter, again, kind of an engineering activity, but it could apply to Earth Day as well in terms of building your own filter using a 2-liter bottle or a soda bottle, and then putting things like cotton balls, dirt, sorry, I'm blanking right now, activated charcoal, cheesecloth. You just give them a lot of different materials to build the best type of water filtration system. And then exploring Earth, investigating clouds, that's a fun activity. You kind of basically create your own cloud in a jar, and then you use a laser pointer to look at it and observe it and check out its different properties. So there are a whole host of other Earth science activities on our STEM Activity Clearinghouse, and as we get closer to that, to Earth Day, I'll be creating a specific collection of Earth Day activities that you can just sort through much easier. Oh, I did want to show you real quick one fun little activity. This is an Earth science activity, and it's kind of heavy on the science, but it's fun, pretty easy, and relatively cheap. This is called Nito Magneto, and this is actually what I'm going to show you is one station within Nito Magneto. Nito Magneto is 4 different stations in which you investigate the properties of magnetism and the fact that Earth has a magnetic field. So this particular one I'm going to highlight, you could just use a styrofoam ball. Or you could use, let me switch cameras real quick. Bear with me while I switch over our camera. All right. So you take just a ball, a styrofoam ball, maybe a little like stress ball. This one's a little bit small, but it still works. But if you just have something styrofoam, the key is that it's something that you can cut open. So you can see here we've cut our ball open, and what we've done is we've placed a magnet with a north-south. There we go, with a north-south like bar magnet in here. So you take just some small staples, and you take staples and you clamp them. So you want to make sure that they're shut so that no kids are pricking their fingers or anything like that. And it's already doing it. And we're kind of researching different other metal materials that you could use for this. But the idea is that you want to model Earth's magnetic field. So Earth is basically a giant magnet. It's got a north pole, a south pole, and it's got a magnetic field. You all have probably seen it before. And so as kids walk over to the station, or adults, they basically just roll around the ball with that magnet in there. Again, a bigger one might work a little bit better, but you can still get the idea here. They roll it around in the ball, and you can see those magnetic field lines. It might be a little bit harder to see on the Elmo cam. They're still a little jumbled. It's not perfect, but you can see those magnetic field lines that travel from the North Pole to the South Pole on Earth. So what you could do after this, you could follow it up by pulling up some actual scientific NASA graphics and showing the actual magnetosphere of Earth. But just a cool little fun activity to do involving magnetism. Oh, nice, Jessica. So now I just have to figure out how to clean this up. Let's see. All right, let me switch back over to the other camera. All right, so again, that is Nito. I believe that particular part of Nito Magneto is station 3 on the activity. And the other ones are a lot of fun as well. Yeah, and so as Kellyanne's saying there, if you guys go in and do any of these activities, please leave a review. Just let us know what worked, what doesn't work. You don't have to be nice. We hope that you will. But it's going to really help other librarians that are logging on kind of figure out whether that activity is right for them or right for the situation. Okay, we are moving on. How are we doing? We're not so bad on time. Maybe a few minutes behind. But we're going to talk about the Mars InSight launch and landing. I like this because this is 2 opportunities to do programming around the specific NASA event. So the Mars InSight lander, it is not a rover like we've been, the last few robotics we've sent to Mars are rovers that go around Curiosity and they take pictures, images, they're collecting data. The Mars InSight lander will be landing in one place and staying in one place for the duration of its mission. So it'll place a single geophysical lander on Mars to study its interior. I have a geology background. This is really exciting for me because it's going to be measuring things like seismic waves, the temperature gradient from the core out. And let's see, it's going to understand the interior of Mars and kind of, because Mars is more of a, on Earth we have a lot of dynamic processes going around on with erosion and deposition and mountain building. And Mars is a little bit more stable and we might be able to investigate more about kind of the early histories of the solar system. Greg, if you could help Chris out with the link to the clearinghouse there. It's going to be using very sophisticated geophysical instruments. It launches on May 5th and it lands on November 26th. So you can be doing activities for both of these. Where will it be landing or launching from? I know we just had a conversation about this. I want to say instead of Florida, it's going to be launching from California, I believe, off the west coast of the United States. Kellyanne, if you would mind verifying that. I know we just had a conversation about it. So I wanted to show you guys the actual lander, and I have a video that I'll play as well. So what you're seeing are, this is a just an animation. The lander has landed in one particular place. It will not be leaving that place. And right here is a seismometer. It is covered by a cap. So a seismometer measures seismic waves. So it's what we use to measure. Oh, thank you, Jeff. It's what we use to measure tectonic activity, earthquakes, things like that. And we have had a seismometer on a mission before, but it was above the ground, so it wasn't really getting great readings. This will be directly on the ground, and from the sound of it, it is crazy sensitive. So it can pick up the slightest vibrations. One of our colleagues was talking about a seismometer. I'm not sure if it was this exact one or one with the same specifications, that here in Colorado, it could pick up waves crashing into the shore all the way in California. So very, 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 very powerful. And then over here, this is going to be its heat probe. I forget the exact depth that it's sending that heat probe down, but it's basically measuring the temperature gradient. And that's going to help scientists understand how hot it is at the core of Mars and how cool it is as you go up to the surface. So they only have one shot to put that probe in because if they hit a rock or something like that, they can't really move around or adjust. Let's see. Before we get to these resources, I want to show you guys a video. And I can't promise if you have a spotty internet connection, this might not play for you, but it's short. It's about a minute long. Let me just pull it up real quick. And I thought the folks at NASA could probably explain the Mars or the InSight mission a little bit better than I could. Let me let it buffer for a second. All right. So what it's doing now, it's landed, and of course this will take, yeah, there's no sound for this. This will take a long time. This is not as fast as you're seeing now, but they're placing, I think that's the seismometer on the ground. They only get one chance to do it. So they'll land, they'll find the suitable place, the best place to put out their equipment, and they only get one shot. So they're placing a cap on the seismometer to prevent wind from interrupting that any seismic signals they may get, or waves that they read, I should say. And again, this will take a lot longer. I believe this is the probe that they'll be drilling into the ground. That's a good question, Tiffany. I would say days. You got to think the scientists at headquarters are sending the information, millions and millions of miles away. So that takes a lot of time, and they can only send a few codes at a time. It's not any real-time direction. So that's them placing the probe in too. Yeah, weeks. I would imagine Anne or Kellyanne might be able to answer that a little bit better. All right. So a couple of resources for this InSight mission. There's a lot you can do with this. We have our own landing page on StarNet. That's where we're going to be posting our own resources. You can, of course, go to the NASA InSight homepage. They have a lot of great resources there, too. I'll be doing a webinar on this on March 13th. I hope to have some special guests, one, maybe two, that can talk a little bit more in depth about the technical side. Look for registration to open for that in mid-February. So let's see. Here are just a few activities you can do. I'm not going to read them off. These are what we currently have available on the clearinghouse. As that day, Colleen, yes, they will. I'll make sure you guys get those. As that day approaches, we'll be kind of creating its own collection and have those a little bit more organized for you. But I want to talk about an activity that is one of my favorites. I say that all the time. This is truly one of my favorites. If you've seen me present at a conference, you have likely seen me do this presentation. It's really fun for adults. It's really fun for patrons, younger patrons as well. It is called Strange New Planet, and the idea is that you're kind of simulating space exploration in general. Some people are like, well, why don't we have powerful telescopes on Earth? Why don't we just save money and use our powerful telescopes to see what's going on Mars? It does not quite work like that. So I'm going to walk you through this activity real briefly and kind of give you the gist of it. But again, it's how we make those decisions to go to Mars, to send a lander. Why are we sending a lander as opposed to a rover? Why don't we send an orbiter to go around the planet? So let's see, let's jump right in. So the first part of this, it's about 4 or 5 different individual components of it. You're going to talk about what we see from Earth. So you'll ask your students, actually the first thing you'll do is create your strange new planet. I have ours here. And it's just basically a mashup of Play-Doh and clay and felt and fabric. You want it to look weird. You want it to be kind of hard to see and hard to pick out what's on it. So you create your planet. The first step, though, you're going to talk about what we see from Earth. Okay. So you, as a facilitator, you might stand 20 feet away from your patrons, and you ask them to create their own telescope. Right. So just take a piece of paper, roll it up, create a telescope, and then for this first step, don't fall out of the chair, you'll put a filter. So this is blue cellophane, and this blue cellophane is pretty easy to find. You can usually find it in the kitchen aisle of any grocery store. So use that blue cellophane, cut out a piece, put it over each patron's telescope, okay? So that it kind of creates that blue haze. Now that's going to be representative of Earth's atmosphere. Earth's atmosphere distorts a lot of things and doesn't allow us to kind of get a full picture of, by Teresa, of what's going on outside of our atmosphere. So with this activity, if you have a lot of kids, this is my favorite part. You can have one be mission control, and they're taking in all the information and recording all the information, and you have one kid that is the actual observer or orbiter or lander, etc. So the first step, you're looking out from Earth. You ask them to come back, report what they saw, right? And they might say, I don't know, it was blue, it was dark, I can't really see anything. Next, you move to out of space. So a telescope view from out of our atmosphere, not blocked by that haze of our atmosphere. So that will be just the telescope, right? No filter on it. And again, give them about a few seconds to look at it, report what they see. And then we're going to move on to a space probe. So we're going to have an unmanned vehicle, if you will, flying out of the atmosphere, getting a flyby look at our strange new planet. This is, of course, Pluto. But as your patrons walk by, they'll walk by with their microscope, or their telescope, excuse me, and they will see what they see, but you can only give them just a little bit of time to fly by, because when we fly by with the probe, we don't have a lot of time to observe. You can see that's a close-up view of Pluto. You can see its little famous heart right there. Roll them by on an office chair, as long as it is safely done. I think that's a great idea. Yeah, because you'll get some folks that spend a little bit too much time doing it. And then next step would be an orbiter. So you'll have one patron, or numerous patrons, kind of orbiting around your strange new planet. Just go stand in the middle, allow them to orbit around, get a view of the planet from all sides, come back, report to mission control. And the final one will be a lander. And you have to emphasize that this will also cost the most money, right? So you kind of, if they're older kids, you can get that budget idea. And you actually have patrons go up, put their telescope right on the planet, and report back what they see. So it is a fun activity. That is just a quick demo, quick facilitation to be able to kind of mimic or simulate what space exploration is really like. Greg, I don't know if I put it in the link banks, but if you could plop in the YouTube recording of our LPI webinar. It's called Hands-On Fun with StarNet. LPI covers that for us, and they do a little bit more advanced presentation of that. So it's on our archived webinar page. You just go to the LPI Hands-On Fun webinar recording, and we have a more detailed explanation. All right, so I'm going to move on to the Parker Solar Probe. Sorry, we're moving a little fast. I want to make sure we have enough time for everything. So the Parker Solar Probe is very, very, very cool. Actually, it's not going to be cool. It's going to be very hot, because it's going to literally, well, almost literally touch the sun. It's going to come within 4 million miles of the sun. And before you say, that's not that close, it's not actually touching the sun, it's going to be experiencing temperatures around 2,500 degrees Fahrenheit, some of the highest temperatures that any NASA mission has ever experienced. And it's going to be moving 7 times closer to the sun than we have ever experienced before. So this is going to be really revolutionary. It's going to be able to provide a ton of new data about heliophysics. It's a fancy word for how information about the sun, how the sun operates. And its launch window is going to start July 31st. So I think July 31st is the anticipated launch date, but they're giving themselves about a 2-week window in case there's bad weather or anything like that. So a really cool, revolutionary mission. And you can see here, I've just kind of put its mission trajectory. Of course, it's not flying from the Earth directly straight to the sun. It's going to be doing a series of orbits, kind of like Cassini did with the Saturn rings. And it's going to be getting closer and closer and closer and closer. Jeff, you are an excellent resource. You need to come to all my webinars. Jeff's pointing out that 4 million miles is less than 2% of the distance between the Earth and the sun. So it's going to be very close to the sun. So as it orbits around the sun, it's going to be getting closer and closer and closer. And its first really, really, really close flyby is going to be December 2024. So that's when we'll be able to kind of start getting that really, really good data and maybe some good images as well. Although I don't know if it does have any imaging software on it. I'm going to pull up a video, another one that NASA did, because they can probably explain it better than me. You guys will just bear with me for a second. And this one should have audio to it as well.
NASA's Parker Solar Probe mission is about to embark on a historic journey to our very own star, the Sun. Named for Dr. Eugene N. Parker, whose contributions have revolutionized our understanding of the Sun, Parker Solar Probe will usher in a new era of exploration. It's a mission of extremes. The spacecraft will plunge through the Sun's atmosphere, called the corona, and fly closer to the Sun's surface than any spacecraft in history. More than 7 times closer. The Sun's surface is hot, at temperatures exceeding 10,000 degrees Fahrenheit. But the real surprise is, its atmosphere is even hotter, 300 times hotter, Facing the corona's brutal heat and radiation conditions, Parker Solar Probe will finally provide answers to some of the most important questions about how our sun works. As Parker Solar Probe speeds.
All right, and I kind of stopped it right there. It's a little bit longer of a video. When I send you the link of resources, the links to those videos are there. NASA always does wonderful, beautiful videos. So Anne said that she hopes the Parker probe is wearing its solar eclipse glasses. That brings me, that's a nice transition, because with this Parker Solar Probe, there's a lot of great stuff specifically about the activity you can do, but this is a chance, if you still have a lot of safe, still preserved solar eclipse glasses laying around, this is a chance to repurpose those. You can throw those on at any point. I still put mine on sometimes and go and look at the sun just to see. I mean, it's cool, you're looking at the sun. You can see, different sunspots on it and things like that. So if you still have solar eclipse glasses and you know that they have not been, deteriorated or have no holes in them, definitely repurpose those for this opportunity. Let's see. The different activities you've done about the sun too. If you still have materials for that, it's a great chance to use those again. The Solar Vision app, that is something that we have developed here at SSI, and it is a real-time view of the sun. It's cool because you can drag the moon over, you can make your own eclipse. But it gives you a real-time, hour by hour view of the sun, and you can see what sunspots are on there and the different filters that you can apply to see, just different views of the sun. I've also linked to the NASA Parker homepage. Once again, there's plenty of resources there. And I wanted to talk about a cool activity that you could do to tie into this. It's called How Big, How Far, How Hot. It's very simple. It's just a sorting activity. And if you open it up, you will see, we've kind of given you a few different sets of cards. So for all three of the questions, how far, how hot, and how big, I believe, you have a set of cards that you can print off. Cut those up. You can even laminate them. That's what we've done. So you can see we have, our few different 9 cards for the how hot game. And you basically give them to your patrons and ask them to sort them in the order that they think, from coldest to hottest, or from smallest to biggest, or from closest to far away. So just an easy sorting game. But when you open up the activity page, it's provided there for you. So I actually want to use this as a chance to test you guys and see what you think of all of these options. Which is the hottest? Let me see if I can get it out there. And which is the coldest of all of these? Let me open these. Okay, so what do you think is the hottest of all of these options? I'm going to have to cover the screen, unfortunately. And what do you think the coldest is? I'll give you guys about 20 seconds or so, and then we'll reveal the answers. Okay, give you about 5 more seconds to answer. That's a great idea, Jeff. Solar telescopes are really cool. It's a special filter that you can put on, or I don't know if some telescopes come with that filter already on. And it allows you to really get a better view of those sunspots. It's a really cool way to view the sun. Just, of course, safety is paramount with that. All right, we're going to go ahead and view these votes. Congratulations, the majority got it right. Yes, comets are the coldest, and the sun's core is the hottest. It does get a little confusing because the sun's corona is hotter than the sun's actual surface. Kind of still a mystery to heliophysicists, but you guys all pretty much for the most part got it right. I'll get the actual measurements up here in a second. All right, there we go. So we'll just spend a second on this. A comet's surface is about 171 degrees Fahrenheit. The sun's core is a balmy 27 million degrees. Yeah, So good job, guys. And then I just wanted to point out this other activity. This is an easy resource. It is called Scale Model of Sun and Earth. Easy, it's just a print off. It gives you a sheet like this where you cut out your sun, and then you can't see it here, but you have a tiny, tiny, tiny little Earth. And it's a way to kind of quiz your patrons, if you will, or have them hypothesize. If I have a sun this big, how small do you think my Earth is? And then you can reveal it. There's also information about distance. So if my sun is this big, how far away do you think my tiny Earth is? And again, it's just an easy printout that you can do and a fun way to spend 10 or 15 minutes. I have a how-to video there that we produced in-house here at SSI. It's a great resource for that activity. Okay, we're moving along. I think we're going to make it. Lights On After School. It is a partnership, or it is presented by the After School Alliance, I should say. And again, this isn't specifically a science event, but it is a way to partner with after-school providers in your community. So let's see. Our webinar that we presented, it feels like it was just yesterday, in like September with the After School Alliance about Lights On After School is can be found on the page, and it'll be in the link bank as well. And they can, Melissa and Dan in that webinar, explain what After School Alliance and what Lights On After School is all about. But again, it's just kind of a way to bring libraries and after-school providers together. So the 2018 webinar on how you can participate in Lights On After School, that'll be in early August, and I'm looking forward to a couple of people from the After School Alliance joining me on that. And let's see. Oh, the last thing, the After School Alliance produced this amazing report this year, kind of just on the state of after-school providers and libraries, and currently how they're interacting with each other. So you can click on that link to read it. It'll be in the list of resources that I send you guys. But I did highlight kind of just a few interesting findings. So they interviewed over 365 after-school providers, and over 98% believe that there were benefits to partnering with public libraries, of course, because you guys are awesome. And 74% had worked with a public library before. You can see primarily elementary school students. That might be a little hard to read, but it says, what are after-school programs and libraries doing together? Well, a lot of that is summer reading and summer learning initiatives, and then library visits and special events are also very big too. So of those partnerships, though, we're finding that a lot of after-school providers that have worked with public libraries aren't doing STEM, so only 29%, and 63 hadn't considered that even a possibility. So trying to kind of get that idea that, like, yes, partner with your libraries, you're doing a good job with that, but you should be doing STEM. Libraries are a place of STEM learning. So check out the full report, check out the webinar recording, because Dan and Melissa give a lot more information than I'm giving you in this quick few minutes. Okay, International Observe the Moon Night. This will be our last event covered, but it is a very, very, very cool event that encourages everybody in the globe, in the entire world, to go out and view the moon on one night. Of course, if you're not able to do it on October 20th, you can go do it another night. It's not really strictly set to that. But I have links to the official International Observe the Moon Night website. Because it was so recent, they still have the 2017 information up there, but I'm sure it'll be updated relatively soon. And I have a link to our 2017 recording with Brian Day of NASA, and he gives great information. I'm stealing some of his slides for this. And the 2018 StarNet webinar will occur a little bit earlier than last year in mid-August. On the STEM Activity Clearinghouse, we have a specific moon collection, so if you're looking for activities, I would head to there. And then this Moontrack website is actually what I'm going to be talking about. This is a really cool resource that NASA developed that really takes you to the moon without, having to travel all the way there. And I'll kind of go into a little bit more detail about that. This is our partner Brian's slides. But it is an analysis tool, so it's used by professionals, and it's used by, Mars Trek too, so it's kind of in that same vein. It's used by professionals, it's used by people, in libraries that just want to really kind of see what the surface of the moon's like. Think of Google Earth, but on the moon, and maybe more features and more cool stuff that you can do with it. So I just want to show you some screenshots from the actual application from the website. So this would be, on the moon's surface looking at a big mountain. If Brian was here, he would know exactly what that feature is. And this is a cool tool where you can drag a line across, in this case, a crater, and you can get that elevation profile to see, how deep is that? So this one looks like I'm not going to do that math, but it's pretty big. It's a big crater. And then this is a really, really cool feature. If you have a 3D printer, you can actually create and generate a 3D printing file from this website for a particular lunar feature. So really, really, really cool stuff. I have a video to show you just this website and use. So, maybe International Observer of the Moon Night, our weather's not great, it's cloudy, you don't have access to a good outdoor space. Using this Moon Trek website and using Mars Trek for the InSight mission would be a great way to still do programming around it. Just let it buffer for a second. So this is kind of a first-hand view of using the website. There's no sound. Just calculating the distance across the crater. That's how you get the elevation profile. So pretty cool. You guys can see it's pretty, it's user friendly. I was able to log on and figure out how to use it the first time. So I'm sure with just a little bit of training, it could be a really good resource. All right. So guys, I can't believe, we actually made it through all of our resources on time, and we have about 5 minutes or so. If anybody has any questions or any comments, any ideas that you have for ways to integrate that into your programming, now's the time. You could feel free to put it in the chat box. And while I see don't forget about NASA's Year of Human Space Exploration. That is a great resource, Jeffrey. Thank you for linking to that. And so, guys, just so you're aware, if you need a certificate of attendance, when I close out the webinar room, it'll direct you to a SurveyMonkey link. We really would appreciate it if you took that SurveyMonkey link. It gives us a lot of feedback. But then at the end of that link, there's a certificate of attendance if you need it for professional development reasons, or of course, if you can email me afterwards, and I'll send that to you as well. We are licensed to live stream and project these. So, Anne, I'm not sure specifically what you're talking about, but all of NASA's resources are public domain. So you're allowed, there's a few ifs, ands, or buts there, like their image of the day is taking in from other organizations. But yeah, any NASA resource you're free to use. There's no copyright on those. And in terms of this webinar, if you want to project and stream this webinar, we would love that. If you project it to a big audience, please let us know so we can report those numbers back. Oh, wonderful, Kendra. I'm so glad to hear that. Successful enough to launch an amateur astronomy club. That sounds like it sounds like something that, we should let our funders know. That's awesome. How much public PR will NASA do to draw attention to these events? That's a great question, Chuck. They have a lot of resources available if you know about them, So I don't want to assume anything, but I personally didn't know anything about the InSight mission or about the Parker Solar Probe until I kind of came into this position and started learning. So I would say once you know about the events and you have the right resource, the right website to go to, that's when you can really unlock all of those resources. So that's part of the reason we did this webinar, is to make you aware. In terms of public PR, I can't answer that. They usually do a good bit of PR and dissemination. Let me pull up the chat box real quick so I get all these questions. Oh, wonderful, Margaret. Oh, so Aaron Gambrel, did you do the lunar and meteorite sample disk certification? Yeah, and NASA on social media is they're awesome. They have a ton of followers. We just did a webinar with their social media manager. So definitely follow their social media accounts and you'll know about what's coming up. Yeah, their Snapchat's good. Oh, that's awesome, Aaron. That's cool to hear that you got to do that certification. You guys are welcome, and please, this is just kind of a brief overview of all these events. So as we get, I think I was planning about 2 months out before each event. Um, oh, Tuesday talk with one of the GPL geologists on the InSight mission. Jeffrey, would you mind? I'll look that up, but if you wouldn't mind sending me like a quick note about that, if you have my email address, that would be awesome. I would love to hear that. Oh, yeah, sorry, I lost track there. But about 2 months before each of these events, we'll do a more detailed webinar that'll kind of give you some more confidence in being able to talk about this, talk about these events coming up, and specific activity ideas with full facilitations. Oh, wonderful. Thank you. And we designate our activities as for which age group is appropriate on the clearinghouse. Uh, but in general, a lot of these are fun to do with adults. I do a lot of these activities at conferences, and if you get the right mentality and the right group of adults, they have a ton of fun with it. So yeah, Strange New Planet is always a ton of fun. Um, for Engineers Week, I would suggest Windy City Tower as a fun activity to do with adults. Yeah, and teenagers even. If you can get teenagers to be involved, then that's a great. They'll really enjoy these activities too. But I know that's a lot easier said than done. Well, wonderful, guys. Thank you all so much for joining us today. I'm going to go ahead and close out the webinar. And when I do, I'll give you a few more seconds. Any last questions, put them in the chat box. But before I do, I forgot what I was about to say. Oh yes, you'll be redirected to the Survey Monkey link and take our survey. Please give us feedback there. You'll get the certificate of attendance. And we look forward to hopefully seeing you a lot in 2018. We're super excited about all these events, and we hope that you are too. All right. So from all of us here at SSI in Boulder, we will see you later, and good luck with all of your programming. And I hope everybody enjoys their holiday season as well. Bye.